On these examples, we're going to determine whether or not the given function is even, odd, or neither. All right, so let's review how to determine that. All right, so our first function is f of x is equal to x cubed minus 4x. So what we're going to do is we're going to replace x with negative x in the function, and we're going to see if we end up with something equivalent to what we started with. Alright, so if I replace x with negative x, I'll have negative x cubed and then plus 4x. So if I look at what's going on here with the signs compared to my original, if I factor out a negative, I'll end up with negative parentheses x cubed minus 4x. And compared to my original, this is the negative of the starting function, which means then this function satisfies the properties of being odd. All right, for part B, my function is g of x is equal to 4 plus x squared over 1 plus x to the fourth power. So we're going to replace x with negative x in the numerator and the denominator and see what we get. So because these powers are even, that's going to make everything positive. And if I look at how this compares to my original, I'm going to find that I got the original function back, which means then that this function satisfies the properties of being even. All right, for function C, h of x is 1 minus x plus x squared. So let's substitute in negative x for everywhere I see an x. Alright, so I get 1 plus x squared. And if I compare this to my original, I obviously didn't end up with the same thing, and I didn't end up with a sign switch all the way through. So this would be neither. It's not odd and it's not even. And then finally for my last function, capital F of x is equal to x over 1 plus x squared. So if I substitute in negative x, I'm going to get negative x over 1 plus negative x squared. So I'll get negative x over 1 plus x squared. And that negative that's in the numerator, I can pull it out in front and have it in front of the whole thing. And if I look at how this compares to my original, this is the negative of what I started with. So this one satisfies the property of being